In this video, we'll talk about absolute value inequalities. And I have here an example of how they might look like. For example, absolute value of 2x plus 5 less than or equal to 3. But they can be greater than or equal to, or strictly less than. So let's see how we solve them. So here I have the definition which you eventually will have to memorize or learn. But where are these coming from? Well, let's take a look at this example here. Write out all the integers that satisfy the inequalities below. So if we have absolute value of x less than or equal to 4, let's write out all the numbers that we think that in absolute value are less than or equal to 4. And I usually ask students to enumerate them, but let's see how that goes. So if I choose -4, -4 in absolute value is 4, so that's less than or equal to 4. -3, -2, -1, 0, 1, 2, 3, and 4. So these are all the numbers, all the integers that are actually less than or equal to 4 in absolute value. And from here we can also extrapolate to 0.1 also applies, -3.9, -2.5, -1.99, right? 2.34, and so on. But what I want to say is that the numbers x, not in absolute value anymore, are numbers that are between 4 and -4. So in other words, if we end up with inequalities in absolute value that look like this, absolute value of x less than or equal to some k value, then x is between -k and k, where k is a positive value. So as you can see, this is what happened in our situation. And of course, if it was strictly less than 4, then we would have -k less than x less than k, or -4 less than x less than 4. Now looking at this inequality, let's write again, let's enumerate all the integers. So absolute value of x greater than or equal to 5. Well, 5, 6, 7, 8, 9, and so on. But also -5, right? -5 in absolute value is 5, which is greater than 5. -6, -6 in absolute value of 6 greater than 5. -7, -8, -9, and so on. So if I want to write these as inequalities, right, because also 5.1, 5.2, I would say x greater than or equal to 5. And if I want to write this as an inequality, I would write x less than or equal to -5. But in order to make sure all these solutions are included, I will use the word or between them, because and it's impossible, right? You cannot have a number greater than 5 and less than -5 at the same time. So in other words, if we see absolute value of x greater than or equal to some k, then, or some positive k, then x is greater than or equal to k, or x is less than or equal to -k, and the same applies when we have strictly greater than k. And this is just for the situation where inside the absolute value you have x. But if you have an expression like the one that we had in the title, like what I mean by expression, absolute value of x plus 4, or absolute value of 5x minus 5, and you have less than k, then the expression is between k and -k. The expression is between k and -k included. If the expression in absolute value is greater than k, then expression greater than k, or expression less than -k. So this you have to memorize, or if you understood how we figured them out here, then you can apply to your inequalities. So here we have a few inequalities to solve. So let's solve the first one. Absolute value of m minus 2 plus 1 less than 5. So the first step is to get the absolute value by itself. So absolute value of m minus 2 less than 4. So what are the numbers that are less than 4? Well, 3, 2, 1, 0, negative 1, negative 2, negative 3, and very close to negative 4, right? So that means m minus 2 is less than 4 and greater than negative 4, right? Because we used, let's call this 1, 2, 3, 4. So if we look at our 4 formulas, the problem that we had was absolute value of an expression less than k, so it was the first one. So we translated from absolute value into a compound inequality. So how do we solve it? Well, we add 2 to both sides, and we get negative 2 less than m less than 6. We graph it, negative infinity, positive infinity, negative 2, 6, and we want between. So the final answer is negative 2, 6. Let's solve another one. Let's solve problem 2. So problem 2, its absolute value of m minus 2 plus 1 greater than or equal to 5. So again, we subtract 1 and we get absolute value of m minus 2 greater than or equal to 4. So the numbers that you can have inside here can be 4, 5, 6, and of course decimals as well. So we are going to say m minus 2 greater than or equal to 4, right? So these numbers in here without the absolute value can be more than 4, or m minus 2 can be less than or equal to negative 4, because less than that is negative 5, negative 6, which in absolute value become values more than 4. So now we add 2 and we get m greater than or equal to 6. We add 2 and we get m less than or equal to negative 2 with the word or between them. So if we draw them, negative infinity, positive infinity, we put the numbers negative 6, 2. So now greater than 6 would be bracket and we shade to infinity. Less than or equal to negative 2 means we put bracket and we shade to negative infinity. But because we have or, the interval would be negative infinity, negative 2, union 6 infinity. And this would be the final answer for problem 2. Let's solve problem 4. So problem 4 has negative 4 greater than or equal to negative 2 times absolute value of 3x plus 1. So first I'm going to divide by negative 2 both sides because I want to get the absolute value by itself. So negative 4 divided by negative 2 is 2. Because I'm dividing by a negative number, the sign of the inequality changes, so it's less than or equal to absolute value of 3x plus 1. And I'm also going to change it into absolute value of 3x plus 1 written first. So 2 less than or equal to absolute value of 3x plus 1 means 3x plus 1 in absolute value is greater than or equal to 2. So what does this mean? Well, taking a look at the formulas that we have here, this is a problem that looks like, let me see, formula 4, right? Formula 4, we have absolute value of an expression greater than or equal to a number, and then the expression is greater than or equal to the number, or the expression is less than or equal to that number. So going back to our problem, this becomes, I'm going to write it here, this becomes 3x plus 1 greater than or equal to 2, or 3x plus 1 less than or equal to negative 2. And we have a compound inequality to solve. So I'm going to subtract 1, 3x greater than or equal to 1, divide by 3, and we get x greater than or equal to 1/3, or We subtract 1, 3x less than or equal to negative 3, divide by 3, and we get x less than or equal to negative 1. So we got these two, which let's graph them. Negative infinity, positive infinity, negative 1 and 1/3. Less than or equal to negative 1, we go all the way to the left and we put bracket. Greater than or equal to 1/3, we put bracket and we go all the way to positive infinity. So the answer is, because it's or, remember when we were doing compound inequalities, is we copy all the shaded regions, so it's negative infinity, negative 1, union 1/3 infinity. We have brackets because of these inequality signs that include equal to. Okay, and let's do a couple more. How about 5, which says absolute value of x plus 2 less than negative 4. Well, if we remember absolute value of something, it's always positive. Now this negative 4, it's always negative. Well, a positive number cannot be less than a negative number. So this means no solution, because there is no number that you replace in there and you apply absolute value over it and you get less than a negative number. All right, and let's do one more. Absolute value of x plus 2 greater than or equal to negative 4. Well, here we have a positive number greater than a negative number. Well, that's true all the time, right? No matter what number I'm going to pick for x, it's always going to produce a number that is greater than negative 4. So that means all real numbers are solutions. And to write that as an interval, that would mean negative infinity to positive infinity. We shade everything and we write it as negative infinity to infinity. And one more problem, absolute value of x minus 5 less than or equal to 0. So here it's a little bit different because my k, it's actually 0. So we are going to say x minus 5 is actually, so this is a positive number and this is 0, right? So when it's a positive number less than or equal to 0, the only time is when it is equal to 0. So we add 5 and we get x equals 5, and this is the final answer. So in this case, the solution of this absolute value inequality, it's not an interval like it was before, but it's an exact number. And I have one more. I know I said one more, but absolute value of x minus 5 greater than 0. What if we had like this? So this was a positive, and that is greater than 0. So how do we do that? Well, x minus 5 greater than 0, right? Or x minus 5 or x minus 5 less than 0, because I could put k and negative k. So 0 and negative 0 is 0. We add 5 to both sides and we get x greater than 5. We add 5 to both sides and we get x less than 5. So x greater than 5 or less than 5, what does that mean? So negative infinity to positive infinity, we put 5, and we want greater than 5, which means we go like this, and then we want less than 5, which means we go like this. So what is the answer? The answer is negative infinity 5 union 5 infinity. And we cannot say all the numbers, all real numbers, because 5 is not included. If we plug in 5 in here, it's going to give us 5 minus 5 is 0. 0 is not greater than 0, right? So we can say all real numbers except 5. But the interval notation and the right way to write the solution is negative infinity 5 union 5 infinity.